This episode of Rhizome is brought to you in part by the Synthesis Security Group and Fuzzy Wuzzy Signal Processing, a venture of Ian Swanke. Copyright 2026. All rights reserved.
Okay, let's dive right in. Today, we're going on a really fascinating journey that connects two things you probably wouldn't think to put together: the breathtaking aerial ballets of Starlings and the hidden, incredibly complex architecture of human society. Picture this. You look up at dusk, maybe somewhere in Europe or North America, and you see this massive, shifting black cloud in the sky. We're talking 100,000 birds darting around at high speeds. These formations are known as murmurations, and to anyone watching from the ground, this motion appears completely choreographed. But there is absolutely no leader directing the display, none. So you really have to ask yourself, how in the world do 10,000 birds fly in such unbelievably tight coordination without just constantly crashing into each other? Well, physicists actually discovered the answer, and it's kind of mind-blowing. A bird isn't constantly scanning the entire massive flock to figure out where to go. Actually, they aren't looking at the whole group at all. They only track 6 or 7 of their nearest neighbors. That's it. This is what's known as a topological interaction strategy. It basically means the bird is only responding to a fixed, tiny number of individuals rather than stressing about everyone else in the sky. And his localized tracking boils down to 3 incredibly simple rules that magically generate this beautiful global order. First up is separation. Basically, don't crowd your nearest neighbors. Second is alignment. Just match the average direction of those nearby birds. And third is cohesion. Move toward the center of those neighbors. When every single bird follows these 3 simple, super local instructions, it automatically produces these massive, complex, lifelike flocking patterns. And again, 0 central control. This brilliantly illustrates a phenomenon in physics known as scale-free correlation. Think of it like this. When one bird suddenly turns to avoid a hawk, that directional change ripples across thousands of individuals almost instantly. It literally doesn't matter if the flock is 100 birds or 10,000, the correlation in motion doesn't depend on the group size at all. It acts a lot like superfluid transport in physics, where a disturbance just moves rapidly and smoothly without losing its structure, which is exactly how they prevent a catastrophic mid-air crash. So, we can easily see how perfectly this works in nature, right? But now, here is where it gets really interesting. What happens when we take these elegant biological rules, these decentralized local interactions, and try to apply them to us, to human beings? Can the exact same math that governs a flock of starlings explain human culture and our social systems? I mean, do we just blindly align with our 6 or 7 nearest neighbors? Well, this brings us to the eye-opening work of researcher J.L. Lemke. He explores how complex, self-organizing human systems operate on an entirely different level than basic biology or thermodynamic physics. He proposes that we live in what he calls ecosocial systems. This essentially means we don't just react to material and physical forces. Our world is heavily co-determined by meaning, by history, and by human interests. Okay, to really get what Lemke is saying, we first got to define a concept called downward causation. In hierarchy theory, downward causation is the phenomenon of how the massive emergent flock of our culture, so our families, our communities, our environments, how all of that subtly steers and constrains us as individuals. It's basically how the higher level pattern of a system ends up dictating the everyday possibilities of the lower level constituents inside it. The contrast here is super fascinating. See, upward causation is the classic reductionist model of science. Elementary particles interacting to form atoms, atoms forming molecules, and on and on. The parts build the whole, right? But downward causation operates in reverse. It recognizes that while sure, you have individual potential, your community and your culture actually limit and shape your everyday behavior. The whole shapes the parts. Let's look at a physical example because this really makes it click. Lemke notes that if you're being jostled in a dense crowd, say you're trying to leave a packed stadium after a concert, you intrinsically have the free will to move anywhere you want. However, if everyone around you is tending to move in one direction, you are way more likely to be pushed from behind than from that emerging common direction. Plus, you're more likely to actually find open space in that exact same direction. So locally, you end up self-organizing into this little micro-convection current. And that is downward causation in a purely physical sense. But here is where humans completely break the bird flock analogy. Unlike elementary thermodynamic or basic biological systems, human behavior is entirely driven by the threshold of meaning. The moment meaning plays a role, our actions are no longer just about spatial positioning or avoiding a collision. They become deeply tied to our personal biographical history, our social networks, and our cultural categories. Let's trace how this builds. A biological cell doesn't depend on historical meaning to function, right? Its significance is totally exhausted by what it's doing organically in the present moment. But human artifacts, they are a completely different story. Lemke uses this great example of a famous ancient sword. The history of who owned that sword carries deep social memories. Those memories completely change how that sword is used, whether it's wielded as a tool or displayed as a symbol of power. And those properties, they aren't found anywhere in the physical metal of the object itself. Because of this heavy reliance on meaning and history, human systems experience what's called scale heterogeneity. I know, it sounds like a mouthful, but it's actually a major departure from simple physics. It just means we constantly mix vastly different scales of space and time into single, everyday actions. You literally cannot cleanly separate different spatial and temporal scales when you look at human culture. They interpenetrate each other all at the same time. Lemke illustrates this beautifully with this incredibly mundane micronarrative. Think about the simple act of writing a short post-it note to someone in your house and sticking it to the fridge door with a little magnet. It seems like the most isolated, small-scale action imaginable, right? But let's actually unpack the true scale of what is happening in that split second. Think about all the intersecting timeframes crashing into that one seemingly simple moment. The physical writing, that takes mere seconds, but the words you write might be referencing an event days away. The meaning of those words might rely on years of a personal relationship, like maybe using a specific pet name. And of course, the grammar and the semantic patterns of the language you're using have a history that spans centuries. All of those vastly different timeframes are crashing together into one single action. And the complexity explodes even further when we look at the physical artifacts you're using. The pencil, the paper, the magnet, they all carry their own intersecting histories. Who made them? From what materials? You've got massive global supply chains at play here. Even the refrigerator itself and the architectural conventions that dictate what a kitchen even is determine the likelihood that your note will actually be seen. The artifacts themselves are just deeply, deeply embedded with human history. This ties in perfectly with the work of Bruno Latour. He argues that human technologies and cultural artifacts act by blackboxing their own origins and histories. They're explicitly designed to function as simple, small-scale tools in our daily lives, like a pencil or a magnet, even though they secretly contain massive global histories and incredibly long-term temporal processes. We interact with a simple little box, completely oblivious to the vast network hiding inside it. So it really ultimately comes down to this comparison. In an elementary system, every single electron is exactly the same. There's no individuality there for a history to attach to. But in an ecosocial system, there is no interchangeability. Every single human action and artifact is uniquely heavy with embodied memory and interpretive history. We aren't just starlings reacting to the physical proximity of our neighbors. We are constantly reacting to centuries of meaning. Ultimately, our ability to survive and even comprehend these massive, complex environments relies completely on our collective memory and our shared meaning-making communication. Because we are physically confined to a human scale in our day-to-day lives, we've had to adapt. We model the higher levels of our society, our cultures, our entire cities, through symbolic resources, language, and stable visual artifacts. We piece the larger world together by sharing information across vast distances and across generations. The rules that keep birds from crashing in the sky are undeniably elegant, but they rely purely on the physics of the immediate present. Humans, on the other hand, fly through a sky that is thick with history, meaning, and tools that carry the weight of centuries. So the next time you think you're flying completely independently, ask yourself, what cultural artifacts are secretly blackboxing their history to act as the downward causation steering your life? It is definitely something to think about. Thanks for joining me for this explainer, and keep questioning the systems around you.
Now available exclusively on Amazon Kindle eBooks, Rhizome Summer 2026, a collection of essays, Rhizome Fall 2026 Book 2.